All right, let's do another balancing in acidic and then basic conditions. We'll start the same way we did before. We figure out what the oxidation state of everything in the reaction is. We know it's a -1 because this is a bromide ion. It's a monoatomic ion. It gets its charge. You might remember this at this point. Well, maybe not. This is permanganate. It's an oxidizing agent. 4 times a -2. Oxygen gets its charge. That's -8. Everything has to add to -1 because this is a -1 polyatomic anion. So this has got to be +7. And you may see permanganate again. Just remember, if it's MnO4 with a -1 charge, manganese has a +7. Might save you some time. Bromine is an element in its elemental form, standard states, 0. And then here's another monoatomic ion with a +2 charge. Let's see what happens. Bromine goes from -1 to 0. So it's losing negative charge in the form of electrons. That is definitely oxidation. Manganese at +7 in permanganate is being reduced to +2. That is reduction. Now, since bromide ion is being oxidized, that makes it the reducing agent. Remember, reducing agents get oxidized, oxidizing agents get reduced. Permanganate is getting reduced from +7 to +2. So this makes permanganate the oxidizing agent. Okay, oxidizing agent. All right, now that we've got that, we break them up into the half reactions. We'll do the oxidation half reaction first. That's going to be the bromide ion. So bromide ion, -1. And it's going over here to Br2. Okay, and then the reduction half reaction, that's going to be our permanganate, MnO4 minus, and it's going over here to Mn2 plus. All right, so let's take a look at the bromide ion. We don't have to worry about hydrogen, oxygen, just this element. And so I need to get the bromines to be the same number on each side. We're done. This is the oxidation half, so you should note that the electrons go on the product side. And indeed, we've got 2 negative on the reactant side, so we need 2 electrons over here on the product side. Over here for permanganate, we've got 1 manganese, 4 oxygens on the reactant side. So we're going to have to add 4 waters, H2O over here. When we added the 4 waters, that gave us 4 times 2, 8 hydrogens over here. So I'm going to have to add 8 H pluses to balance the hydrogens, which are on the reactant side of the reduction half reaction. Now we're going to balance charge. We balance charge by adding electrons. I've got a 2 plus charge over here on the product side. Over here I have 8 plus a negative, which gives me 7 plus on the reactant side. In order to get it down to 2 plus, I have to add how many electrons? Looks like 5 electrons. So 5 electrons plus 1 negative charge. That's -6 plus 8 plus, which is +2. Now charge is balanced. So I have an uneven number of electrons being lost and gained. And so in order to get them even, I have to multiply. I have to change the coefficients of both of these reactants. So since there's 2 electrons being lost, 5 electrons being gained, to get them to be the same, I'll multiply every coefficient in the oxidation half by 5 and every coefficient in the reduction half by 2. And so I'll get that done. Okay, so I've gone ahead and I've multiplied the oxidation half by 5, the reduction half by 2, to get the number of electrons lost and gained to be the same. So I have 10 electrons lost in the oxidation half. Now that they're the same, I can go ahead and cancel those. It doesn't look like there's anything else I can cancel, so I'm just going to add up the two half reactions. All right, I have added up the two half reactions. Let's just double check. 10 bromines, 5 times 2 is 10 bromines. 2 manganese, 2 manganese, 2 times 4, that is 8 oxygens. 8 times 1 is 8 oxygens. 8 times 2 is 16 hydrogens, 16 hydrogens. Charge, 2 times 2 is 4 plus on the product side. I have 2 negatives plus 10 negatives. That's 12 negatives plus 16 positives, which gives me a 4 plus on the product side. So this is balanced in acidic conditions. To balance this in basic conditions, all I have to do is add an equal number of hydroxide ion to the number of hydrogen ion. That's going to give me 16 H2Os. Now, I have to add the hydroxide to both sides. You can't add something to one side without adding it to the other side. So I'm adding 16 hydroxides over here. Now, when I added the 16 hydroxides, that gave me 16 waters over here. I also have 8 waters on the product side, so I can get rid of 8 of those waters. So this 16 waters is now 8 waters. So just to double check on the hydrogens and oxygens, because I did some manipulation here, I've got 8 times 2, which is 16 hydrogens. Here I have 16 times 1, 16 hydrogens. I have 16 oxygens. Over here I have 8 oxygens plus 2 times 4 is 8 oxygens. So I'm still balanced, but now I'm balanced in basic conditions. The reason it's basic is because I have excess hydroxide. That is our base. Okay, so now I've balanced both in acidic conditions, which you do first, and then you just add hydroxide to the hydrogen ion. Don't forget to add it to the other side as well. And that gives you balanced in basic conditions. Here's a quick little problem, clicker problem. For the following partially balanced half reaction, we're just going to balance oxygen by balancing with water. And the way we balance, we look at the number of oxygens on each side. I have 4 oxygens on the reactant side, 2 times 3. There's 6 oxygens here. There's 4 oxygens here. So to balance with water, to balance the oxygen with water, I add 2 H2Os here. That gives me 2 more oxygens plus 4 is 6. So the answer would be 2 water molecules to the reactant side. So we've already talked about this, balancing redox reactions in basic solutions, same as in acidic solutions until the last step. Then you simply add hydroxide. You neutralize the H plus with hydroxide to convert to a basic solution, cancel out the excess water if it appears on both sides of the equation. So here are 2 reactions. Let's just get right to it. Already set it up. So first thing, Same thing we've been doing. You figure out the oxidation states so you can figure out what got oxidized, what got reduced. One species that's going to get both oxidized and reduced. Okay, and this is a monoatomic ion, so it gets its charge at -1. And then we have to figure out this one. This is hypochlorite ion. Oxygen gets its charge at -2. Remember, the charges have to add up to -1. So this is chlorine with a +1 charge. Okay, and you've probably used hypochlorite ion if you've ever used chlorine bleach in the wash. Cleans out stains. Okay, all right, so now that we know that, we're going to write the half reactions. Let's figure out what happened here. So chlorine went from 0 to -1. That's a reduction. It's gained an electron, and then another chlorine went from 0 to a +1. Its oxidation state increased. It lost electrons, so that's a positive oxidation state. So here we have our oxidation half reaction, Cl2 going to OCl minus, and then the reduction half reaction, that's going to be Cl2, and that's going to Cl minus. All right, let's go ahead and get her balanced. I got 2 chlorines, only 1 over here, so I need to multiply that by 2. I have 2 oxygens on the product side, so I need to add 2 H2Os over here on the reactant side. That gave me 4 hydrogens, so I have to add the 4 hydrogens over here. And now we're going to balance charge. We know that the electrons, they have to go on the product side. I have 0 net charge on the reactant side, 2 negatives plus 4 pluses. That gives me a 2 plus excess, so I'm going to add 2 negative charges. 2 negatives plus 2 negatives is 4 negatives plus 4 pluses is 0, which is the same as the reactant side. Let's do the same thing over here. Well, this was easy. All I had to do was do that, and then we balance charge by adding 2 electrons. So 2 electrons added to this side. Let's move them a little closer. That's a little bit wild. Okay, it's late. So we're adding 2 electrons to the reactant side, which we would do on the reduction side. All right, now that I've got that, and oh, hallelujah, we do not have to multiply because the number of electrons being lost is the same as the number of electrons being gained. There is nothing that I can cancel other than the electrons. Let's go ahead and add things up. I've got 2 H2Os plus 2 Cl2s. That gives me 2 OCl minus plus 2 Cl minus plus 4 H pluses. All right, so I've got 4 chlorines. 2 chlorines plus 2 is 4 chlorines. 2 oxygens. 2 oxygens. No charge on the reactant side. I have 2 negatives plus 2 negatives. That's 4 negatives plus 4 plus. So we are balanced in acidic conditions. Just like before, we're going to cancel, or we're going to neutralize the H plus by adding 4 hydroxide ions. That's going to give us 4 H2Os. We got to do the same thing over here, add the 4 hydroxide ions, because you can't do one thing to one side and not do the same thing to the other side. And so the 4H pluses, OH, that gives us, oh, look at here. We've got 2 waters on the reactant side, 4 on the product side. So I'm going to cancel 2 of these waters. We are now balanced in basic solution because we've got 4 hydroxides. We've got excess hydroxide here. Okay. Last one. Let's go ahead, do our thing, figure out the oxidation state. Aluminum is an element in its elemental form, has an oxidation state of 0. We've already worked on permanganate enough. You know it's a +7. Let's figure this one out. -2. 2 times -2 is -4, so that's going to be a +4. For manganese there. And aluminum in compounds and ions is always +3. So we're good to go. So aluminum is going from 0 to +3. That's clearly oxidation, which makes aluminum the reducing agent. Okay. Permanganate is going, manganese is going from +7 to +4. Its oxidation state is being reduced. +4 is lower than +7. That makes permanganate the oxidizing agent. Okay, well, let's write the half reactions. The oxidation half reaction is going to be our aluminum. And our aluminum is going to this tetrahydroxy aluminum anion. Okay, and then the reduction half reaction, this guy right here, that's permanganate, MnO4 minus 2MnO2. All right, let's do it. So I got 1 aluminum. I've got 4 oxygens on the product side, so I need 4 H2Os over here. That gives me 4 times 2 is 8 hydrogens. I've already got 4, so all I need to add is 4 H pluses. 4 H pluses here, 4 H's here. That's a little sloppy. That is hydrogen, ladies and gentlemen, trust me. And so that's all balanced. Now we need to balance charge. I have no charge on the reactant side. This is oxidation, so we know the electrons have to go over here. And so I've got 4, I got a negative charge and 4 plus 1, so I need to add 3 electrons. 3 electrons, 3 negative charges, plus this negative charge, give me 4 negatives, plus 4 positives, give me 0, which is what I have on the reactant side. On the reduction half, I've got 1 manganese, 2 oxygens on the product side, 4 on the reactant side, so I'm going to add 2 waters to balance the oxygen. That gives me 4 hydrogens, so I need 4 H pluses here. Okay, let's balance charge. There's no charge on the product side. And once again, 3 electrons gets it done. Okay, now that I've balanced mass and charge, I can cancel the electrons. And I can also cancel these 4 protons, but that's going to, this is going to be interesting. I've got 4 waters over here. I can get rid of 2 of them. I can get rid of all of these and knock this down to 2 waters. And so let's see what we got. I got 2 H2Os plus I've got aluminum plus permanganate. And that gives me this manganese, oops. plus what is left? The tetra aluminum. Dude. Okay. So 2 times 2 is 4. 4 hydrogens, 2 oxygens plus 4, that's 6 oxygens. 2 oxygens plus 4 times 1, that's 6. 1 aluminum, 1 aluminum, 1 manganese, 1 manganese. I have a negative charge on the reactant side, a negative charge on the product side. And notice there's no XSH plus, so there's nothing for me to neutralize with the hydroxide. So this is one of those reactions that balances the same in both acidic and basic solutions. So this satisfies both.